We're going to have a look at our logarithm laws. Now, logarithm laws are very closely aligned to our index laws because they're essentially dealing with the same thing, exponents or power. So let's jump in and look at our first one straight away. So if I had logarithm of base a x plus logarithm of base a y, it's actually going to equal logarithm of base a, and it's important to note that all of these are going to be working with the same base. You must have the same base before you can do anything. That's going to be logarithm of base a, the product of x and y. Now, if we look at our first index law, a to the power of m times a to the power of n, it actually equals a m plus n. It's a bit of a reverse situation here. I'm essentially saying the power of x plus the power of y over this side here is going to equal the product here. You see it's just reversed here. If we're multiplying two products here, they're going to add. So they're very, very, very closely aligned, in fact, derived from one another. So if I was to look at an example of this, it's pretty straightforward. Let's pretend I had a question that asked us to evaluate log base 10, 20 plus log, same base 10, 5. That's simply going to equal log of base 10, 20 times 5, which equal log base 10, obviously 100 here. And we're essentially now asking what's base 10. So let's convert this now to index form. So I'm going to do this over here. Oh, no, I can still do it here. So I'm essentially going to ask base 10 to the power of what is going to equal 100. So here, it's the same thing here. If I convert that to base 10, it would simply then equal, will be 10 squared. So x would actually equal 2 is my final answer. So I could have also, instead of doing it like that, I could have also changed this to use base 10. So I could have said log base 10, 10 squared. So therefore, it will equal 2 as our answer. First law, pretty simple. Second law is going to be derived from the second index law. So let's change this to law 2. It says that log base a x minus log base a y is going to equal log base a again x divided by y. Now, if we look at our second index law, that will be a to the power of m divided by a to the power of n will equal m minus n. So again, we just have the inverse. Again, they're really closely linked because they're dealing with the same things, exponents or powers. So an example of this may be log base 4, 20 minus log base 4, 5. Well, if we were converting it here, they both have the same base, so we can apply our law here. It will simply be 20 divided by 5, which is going to be log base 4 of 4. So it's essentially saying, what power do I need to take base 4 to get 4? And we know that's going to be 1. Pretty simple. So we have law 1 and law 2 mirroring our index laws very, very closely. So let's take a look at law 3. So our logarithm law 3 states that logarithm with base a s to the power of n is simply going to be n out the front, logarithm base a to the power of x. So if you look at the only thing that's essentially changed is instead of having x to the power of n, I can then take n out the front as a product of the whole logarithm. A good example of this would be, let's go to logarithm base 6, 3 plus logarithm base 6 and 4. Well, I'm going to now, this is a bit of a reverse situation. So I have it in this form right here. So instead of having 2 log base 6, 3, I'm going to rewrite that a little bit. So instead of having 2 log base 6, 3, I can have just log of base 6. I can take my 3 out there as a power, so it becomes 3 squared, like that, plus log base 6, 4. So we know what 3 squared is, so it becomes log base 6 of 9 plus log base 6, 4. I'm adding them together. So again, we know we can, from our previous law, go log base 6, 9 times 4, which equals log base 6, 36. So we're saying 6 to what power will make 36. So if we were to convert that here and change that to base 6, we know that's going to be 6 squared. Therefore, my answer is going to be 2. Okay, pretty simple stuff. Just converting one way or the other. So whenever you have a product out the front, it can be taken to the end as a power. Similarly, if I had a power and I wanted to get rid of that power, I could bring it out the front of the log as a product. Pretty straightforward. Now the rest of the laws are a bit simpler than all those other ones that have come before it. There. So law 4 simply says that any logarithm to base a, it doesn't matter, 1 is going to be equal to 0. The reason for this, if we write this in index form, so we know that a is going to be our base, 0 will be our power, so it'll be to the power of 0, and anything to the power of 0 is always going to equal 1. Pretty straightforward stuff. So let's go law 5. Now, our logarithm law 5 says that the logarithm of base a is going to equal to 1. Again, if we write this in index form, it's going to make more sense. So we know we have a base of a, and it's going to be a power of 1. So anything to the power of 1 is simply going to equal itself. Pretty straightforward stuff. Law 6. Now, law 6 says that logarithm to base a 1 over x is always going to equal the inverse base on the other side. So it'll be negative log base a x. So we can see this, or this is best understood if we think about what happens when we use a negative power. So if we took 10 to the power of negative 2, we know that it then becomes, 10 squared, but it all happens over 1. So it's the same deal up here. We have 1 over x, so it must mean that whatever power we use represented by a logarithm is going to be negative. And our last law, which is nice and easy, log law 7, it says that logarithm with base a to the power of x is going to equal x. Again, we'll rewrite this in index form just so we can get a better look at it. So we're saying that a here, base a to the power of x is going to equal a to the power of x. Pretty straightforward stuff. But once you master all of those logarithm laws, you can do a whole lot of different things with them. If we were to, well, we could go through some examples, but I will save that for another video. But that's your logarithm laws, 7 laws, pretty easy to use.